everyone, and welcome to the Mat 211 review on extreme values. My name is Julia, and I work for the tutoring centers at ASU. So for today's problem, say we have the function f of xy equals x squared plus 4y squared minus 2 times x squared times y plus 3 on the rectangle given by -1 is less than or equal to 1 is less than or equal to 1, or is less than equal to x is less than or equal to 1, and -1 is less than or equal to y is less than or equal to 1. So we want to find the extreme values over the given region, which is this rectangle. So in order to do this, we need to find all of the critical points of f of xy. We need to find the corner points of the region, and we need to find the boundary points between the region, or at the edges of the region and this function here. So let's start by doing the critical points. To do this, we need to first find f of x and f of y. So those are going to be f of x equals 2x minus 4xy. And that comes from, because this term goes away, so we're only taking, the derivative of this guy and this guy. That one goes away too. And then we have f of y is equal to 8y, so derivative of 4y squared minus 2x squared, because the derivative of y here is 1. So these are just coefficients in this case. Now we want to set each of these equal to 0, and that's going to be our system of equations. So our system looks like 2x minus 4xy equals 0, and 8y minus 2x squared equals 0. So we want to find system or values for x and y that solve this system. Let's start with our first equation here. So we have 2x, or minus here, not plus, there we go, minus 4xy equals 0. Well, we can factor out a 2 here. We can just divide 2 from both sides. That'll give us x minus 2xy equals 0. We can also factor out an x from the left side. So that'll give us x, and then times 1 minus 2y, and that equals 0. So what this means is that either x equals 0 or 1 minus 2y equals 0. And from 1 minus 2y equals 0, if you subtract the 1 over to this side and divide the -2, or divide that by -2, you get y equals 1/2 here. So we have either x equals 0 or y equals 1/2. So we're going to consider both of these cases separately and find the corresponding values of the other variable. So let's start with x equals 0 here. So let's plug this into our second equation. And that gives us 8y minus 2 times 0 squared equals 0. So you've got 8y equals 0, because that just goes away. And so if you divide out your 8, you still get y equals 0. So our first point here, and I'm going to write it up in the corner here, our first critical point is going to be 0 of 0. And if we look at this, you always want to verify that every one of your points is going to be in your range here. And we see that 0 is right in the middle of our x and y values. So now let's look at the case where y equals 1/2. Again, we're going to use our second equation here since we got this from our first equation. So we have 8 times 1/2 minus 2x squared equals 0. So that's going to be 4 minus 2x squared equals 0. We can divide out a 2 from both sides here. That's going to give us 2 minus x squared equals 0. And then if we subtract our 2 over to this side, we'll get negative x squared equals -2. Divide everything by -1. X squared equals 2. And so x is going to equal either plus or minus the square root of 2. So remember, you could either have negative 2 times -2, or negative square root of 2 here, and that would equal 2. Or you could have the positive versions of these, and that would also equal 2. So don't forget your negative branch. So what this means is that we have the 2 points, let's see, negative square root of 2, 1/2, right? And positive square root of 2, 1/2. However, the square root of 2 is outside of our region, and the square root of -2 as well. It's a bit greater than 1. So neither of these points are in our region, so we don't care about them. So we can just get rid of them. So we only have the critical point 0 and 0 in this case. And again, always check, because you don't want to be using points that are outside of your region. So we have our critical points now. So we don't need any of this anymore. Next, we want to find our corner points. And for that, we're just going to look at the region by itself. So let me make a little space here. Erase, 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 erase. All right. So let's think about what our region says here. So we can be as small as -1. So our lower boundary in the x direction is x equals -1. Or we can be as large as x equals 1 in the x direction. And the same goes true for y. We can have y as small as -1 and y as large as 1. So if we think about this in terms of graphing this, we would have, say this is like, that's our -1, that's our +1, and then we've got a 1 and 1 here. So each of these corner points here, let's make those red. Each of these corner points here is a possible extreme value. So we want to check them. So since this function here is going to be x equals 1, and this function here is going to be y equals 1, we're going to have a point here 1 and 1. Same, we're going to have a point 1 and -1 here. And then we're going to have -1 and -1 here. And nope, that's a negative. -1 and 1 here. So all of these are inside of our region, since each of these is a greater than or equal to. So we know that they are all possible extreme values. So let's write them all up in the corner here. So we'll say corner points. We've got -1, 1, got 1, 1, got -1, -1, and we've got 1 and -1. So the last thing we want to do is we want to find our boundary points. And so to do this, we want to think about each of these functions that we had for the boundaries, with respect to x and y. And we want to substitute those into our function here and then take the derivative of that resulting function. And then we set that equal to 0 and solve for points. I'll show you what that means. So let's start with our x equals -1 here. So we're going to say f of x, well, f of 1 y here, right, is going to be 1 squared plus 4y squared minus 2 times 1 squared plus 3. So that gives us 1. So if we simplify this, let's see, we've got a 1 plus 4y squared minus 2 plus 3. So that's going to equal 4y squared plus 2. And now we want to, oh, nope, you know what? We forgot a y here. Always forgetting that y. So let's fix that. So we've got a y. So 2 times 1 squared times y plus 3. That's negative 2y plus 3. I knew that didn't look right. So then in this case, we have minus 2y and plus 4. Okay, now we want to take the derivative of this. So let's call this function here, just for make it less confusing here. We're going to just call him g of y for right now. And we'll say that the derivative of g of y is going to be 8y minus 2. We're going to set that equal to 0. So then we have 8y equals 2 if we add a 2 to both sides here. So y is going to be 1/4. And we got this from the point x equals -1. So we have a point here that is -1 and 1/4. And both of those values fall within our region. So we can add this to our list. So we're going to say our boundary points here. We've got -1 and 1/4. So now we want to use the case where x is equal to 1. So we'll just go ahead and, oh, and that was supposed to be negative, by the way. Oh, and actually it looks like I did all of these. Dang it. All right, so this was all supposed to be 1 here. I just went ahead and did the 1 first. So we'll do the -1 now. Perfect. My apologies. I always forget my negatives. So, okay. Now that we have this one, we can go ahead and do the -1. X equals -1. So in this case, we'll put the negative back here. And we'll say that that is -1 squared. It's probably not going to look much different. Plus 4y squared minus 2 times -1 squared times y plus 3y, or plus 3. And that's going to again give us 1 plus 4y squared, and then minus 2. And this is just going to become a 1 since we square it. So minus 2y plus 3. So yep, pretty much the same exact thing here. We got 4y squared minus 2y plus 4. And again, our derivative here with respect to y is, so if we call this g of y here, just for clarity, is going to be 8y minus 2. We'll set that equal to 0. We already know what this means. This means that y equals 1/4. So in this case, then we also have the point -1 and 1/4. And again, we know that that is in our region here. Great. So now let's look at the point where y is equal to -1. So we can just clean up here again. So we're going to say that sum x and y is -1. And so that'll be x squared plus 4 times -1 squared minus 2x squared times our -1 here plus 3. If we go ahead and simplify this, we've got x squared plus 4. And then it's a minus, but this is also a minus. So we got plus 2x squared. And we got a plus 3. So that gives us 3x squared plus 7. We'll call this, I don't know, h of x. Why not? Let's take the derivative of h of x. That's going to be 6x. And it's just going to be it because this will go away. And so if we set this equal to 0, we see that x equals 0. So when y is -1, x is equal to 0. Both of those are in our region. So we can say 0 and -1 for our next point. Lastly, let's do the case where y is equal to 1. So we'll just do it over here. x1, so again, we got x squared plus 4, 1 squared minus 2x squared times 1 plus 3. If we simplify that, we've got x squared plus 4 minus 2x plus 3, 2x squared, excuse me. And so that gives us negative x squared plus 7. And we'll call this one h of x now too, sure. Oh, this one's gone. So h of x prime, so that's going to be -2x, and let's set that equal to 0. We see once again that x is equal to 0. So we have the point 0 and 1 as well. And this is all of our potential extreme values, at least all of the ones that are in our region of interest in our rectangle here. So let's make a little space. The last thing we need to do is we need to test all of these values. We need to plug all of these particular coordinate points into our original function here to see which ones are the largest, produce the largest value, and which one produces the smallest value. So the minimum and maximum here. So I'm not going to go through this in great detail because I think it should be fairly easy to go through and solve this for yourself if you want to check. But again, you just stick all of your x values in here, all of your y values in here for each point, and then find the value. So f at 0, 0, if we start from the top here at our critical point, that's going to be equal to 3. Our f of -1 and -1 here is going to be 10. F of 1 and 1 is going to be 6. F of -1 and 1 is going to be 6 as well. F of, nope, that's a +1. F of +1 and -1 is going to be equal to 10. And then we've got f of -1 and 1/4. That's going to be equal to 15 over 4. Running out of room here. F of 1 and 1/4 is going to be 15 over 9. Come up here. And we've got f, last 2 points here, f of 0, -1 equals 7. And f of 0 and 1 is also equal to 7. Great, so that's all of our values. So lastly, we want to identify which of our values is largest and which of our values is the smallest. So it happens that this guy is our minimum. And our maximum is at this point and at this point. So these are our max. So what we can say is our minimum value is 3 at the point 0, 0. And our maximum value is 10 at points -1 and 1 and 1 and -1. And that's our solution. right, so before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support services at ASU, you can go to our website, tutoring.asu.edu, right here. If you go to the main page or to this link here, you can find the tutor search tool, which allows you to find tutoring services for your specific course. So thanks so much and have a good rest of your day.